Question 1 here talks about this. Describe the transformation. So this is not the question, but if the question was this, 4 to the x plus 3, then that would be 3 units up. Same as we did the previous section. If we had y equals 4 to the x minus 7, that would be 7 units right. Question 2 here talks about sketching the graph, and we can do that quite easily. We're going to look at another equation, y equals 2 to the x. If we plot the points for 2 to the x, we've done this before. X, y, we go -2, -1, 0, 1, and 2. We know that x is 0, we get 1. If x is 1, we get 2. 2, we get 4, because 2 squared is 4. 2 to the -1 is a half, and 2 to the -2 is a quarter. So when we come to graph this out, we get this graph that looks like this, like that, like that. It's done very roughly, but we get this curve shape coming down here. Not drawn very well, I know. But c'est la vie. And of course we get an asymptote. Just want to make this asymptote a little bit bigger in terms of what it looks like. There's the asymptote there. Of course, now if we come to graph something like y equals 2 to the x plus 1, i.e. a vertical shift, well, everything shifts, including the asymptote. And the graph will now look like a little more, it will be like this. There's the axis there. Every point gets shifted up 1, and the asymptote ends up being shifted up 1 as well. And that asymptote now has the value y equals 1, which coincidentally will be the same as this value here on the end of the equation. So the asymptote will reflect that value there. If we look at y equals 2 to the x minus 1, this is just a shift of 1 to the right. And for this graph here, everything gets shifted 1 to the right. The graph has exactly the same shape, except it's just every point is 1 to the right. And funnily enough, the asymptote stays the same. It's still y equals 0, because when you shift a horizontal line to the right, it's still the horizontal line. Question 3 here, we're going to come up with an equation. Gone to green for some reason. Write the equation for the function that results from each transformation applied to y equals 5x. So let's have a look at y equals 2 to the x again, so it doesn't make it, not doing all the work for you. A says translate 3 down. So 3 down, I think everybody should be able to work this one out. It's going to be y equals 2 to the x, and then the 3 down just becomes minus 3 on the end. If we look to B, 2 right, well, that's going to be y equals 2 to the x, and then 2 to the right is going to be the x, and then the 2 to the right is going to be minus 2 after it. Fairly easy question. Question 4 here says describe the transformation. So we'll look at the graph we were looking at before, which is, say, 1/3 times 2 to the x, and we know that the number in front here, x on the y, so therefore it's a vertical compression because it's less than 1. And the compression is of factor 3, but of course if you put factor 1/3, you would not get it right. Wouldn't get it wrong. You're dividing by 3 the y value, so the factor is a factor of 3, or multiplying by 1/3, same thing. Question 6 says write the equation for the function that results from each transformation applied to the base function y equals 7 to the x. Well, let's have a look at y to the 2x as we've been looking at this all the way through. A talks about reflection in the x-axis, reflect x-axis, And of course the x-axis is the one that flicks it up and down, so therefore that's going to be fairly straightforward. Y equals negative 2 to the x would be that. B talks about stretch vertically by a factor of 3, so vertical stretch vertically times 3. That would be y equals 3 times 2 to the x. Can't do multiply 3 times 2 because these two things are different, so you could put a bracket around the 2 to the x like that. Question 7 sketch the graph of y equals negative half 2 to the x minus 4. Well, you know that the original graph, so y equals, let's just keep that one still a bit, shall we? Let's have a look. There you go. So y equals 1/2. So y equals negative 1/2 2 to the x minus 4. Okay, so we know the original graph of this would look like, go through 0, 1, 1, 2, 2, 4, and 3, 8 up there. And then it would asymptote down, so this one would look, do a little dotted line here. If I can, if I got the nice little touch, I do, there. And goes all the way like that. So the x minus 4 takes everything 4 units to the right. So that would put a point there, and then next one up would go to 2 squared 4, and then up there to 8. So that would be that one. That would be shifted 4 units to the right. And then the negative sign here would flip it upside down. So that would put all the points there, there. That didn't look very good, did it? Let's get those two away. So you'd have a point there, and there, and there, and there. So that's the new graph, which would look something like this. If I just do it nice and delicately. So that's with the negative sign. And then the y values get multiplied by a half or reduced. So every y value then becomes half, and we get a graph that just condenses up very tightly and comes up like that. And that would be y equals negative half 2 to the x minus 4 with the shifts. Question 8, exactly the same thing. You've got y equals 3 to the negative 0.5x minus 1 minus 5. And what we could do is actually plot some points on this one. And then if we plot a couple of points, plot 3 points and see what happens. Because the most important points will be 0, 1, and 2. If x is 0, we get 1. If x is 1, we get 3. And if x is 2, we get 9. So for the function over here, the negative 0.5x minus 1, the way we do this, we do the shift first, 1 to the right for the x. So for 0, that would give me 1, 2, and 3. That would give me 1, 3, and 9. The y values stay the same. And then we multiply, we divide each x value by negative 0.5 because it works opposite. So we divide by negative 0.5, and 1 divided by negative 0.5 is negative 2. That becomes negative 4. Divide 2 by negative 0.5 and divide that by negative 0.5, we get negative 6. And the y values stay the same. And then the last one is to do the y's, which is to subtract all those values, y values, with 5. So the x values stay the same. And then the y value becomes negative 1 minus negative 5 is negative 4. 3 minus 5 is negative 2, and 9 minus 5 is 4. And then we graph these points. If we graph the points, negative 2, negative 4 is down there. That's negative 2, negative 4, and that will be one of the values. Negative 4, negative 2. Negative 4, negative 2 is there. And negative 6, 4 is 1, 2, 3, 4, 5, 6, and 4 is up there. So you can see straight away this graph is coming down like this and asymptoting in here. And what's the asymptote? Well, we go back to the original equation. The asymptote is going to be that, y equals negative 5. So we can draw that in, and I think it's going to be here. Let's put it in green, as we like green so much. There's the asymptote there, the graph getting closer and closer to it. But all from plotting just 3 points there, 1, 2, and 3. Question 9, the temperature T is given by that function. Let's just write it out. T of T equals 20 plus 100 and 0.3 to the 0.2t. A says, sketch the graph of the relation. Okay, so we know that this is going to have a asymptote of 20. Let's put that in straight away. Y equals 20. We know that's the minimum value. Now it's 0.3, so therefore there is some decay, so it's going to go the other way, because if t is 0, 0.3 to the 0 is 1 times 100. 120 is the y-intercept. That's when t is 0. If t is, say, 5, and the reason I've taken 5, because 5 times 0.2, let's just do a little chart here, so we know that when t is 0, so it's not x or it's t, isn't it? So it's t and big T, T of t. That's the y value. So when t is 0, we get 120. When t is 5, 5 times 0.2 is 1. 0.3 to the 1 is 0.3, and 100 times 0.3 is 30. 30 plus 20 is 50. So we know that when, and 50 is going to be about here, and of course so 550 is about here, and of course the mistake I've made is the asymptote's completely messed up, because it's going to go through 20, which is down here. So my apologies for that. This graph will come down like this, and asymptote like that. And of course that's a decay graph, and we know it's decayed because this is 0.3 less than 1. B, what is the asymptote of this function? We know that is t equals 20. So y value, so therefore it's t equals 20. How long will it take for the temperature to be within 0.1 degrees of the value of the asymptote? So what you're trying to do there is substitute a value so that 20.1 is what you're trying to get to, equals 20 plus 100, 0.3 to the power 0.2t, and you have to solve that. And of course what we're going to do first is subtract 20 and then divide by 100. Okay, last question we're going to do here. We're going to look at this one. Graph the function of f of x equals 1/2 to the power 1/2 bracket x plus 2. Says what's the domain? Well, the domain is going to be fairly easy. Domain is going to be all real numbers.
I'll just bang on the door tomorrow, so you're here.
2 says the range. Well, the range is going to be, as there's no number at the end here to put the asymptote away from y equals 0, the asymptote is still going to be y equals 0, so the range is going to be y greater than 0, not greater than equal to just y greater than 0. The equation of the asymptote is going to be y equals 0 because there is no number after the exponential part.